Hello my dear students, welcome to my channel Fluid Mechanics Lecture Series. I am your SumamMiss. My channel name that is also SumamMiss. So please watch my videos, comment. I am just awaiting your comments. Today we are going to discuss about the measurement of pressure. So before going to the discussion on the measurement of pressure, let us start our discussion about the pressure variation in static mass of fluid. Pascal's law states that intensity of the pressure at any point in static mass of fluid is equal in all directions. Similarly, transmissibility of pressure states that if certain pressure is applied to an incompressible liquid enclosed in a container is under equilibrium condition due to the action of external forces, this pressure is transmitted to any point in the fluid without any change. Hydrostatic law states that the pressure at any point in static mass of fluid depends upon its position with respect to the free surface and specific weight of the fluid. That means P equal to rho g into H, or P equal to H rho g. Here I have written that P equal to S into rho g into H. So rho g indicates the specific weight of water and S into rho g which indicates the specific weight of the corresponding liquid. Okay. So P equal to S into rho g into H, or in other words we can write H means that is a pressure head equal to P divided by S into rho into G. So H indicates the pressure head in terms of liquid column with a specific gravity of S. So the relationship between this pressure and head that is utilized for the measurement of pressure in manometer or liquid gauge. So piezometer is the simplest form of manometer, which is a glass tube open-ended at both ends. So if you want to measure the pressure using piezometer, that will be inserting into a pipe or a vessel which contains liquids under pressure, and this liquid that rises through this tube to a particular height h. This h indicates the pressure head. By using the piezometer, we can measure the pressure head directly. The piezometer which measures the static pressure head of the liquid, and this diameter of this tube that should be higher than 10 mm to eliminate capillary effect. Since open end is exposed to atmosphere, the piezometer shows the difference of pressure between atmosphere pressure and the pressure of the liquid. Hence, the pressure measured is gauge pressure. Now, let us look into the limitation of piezometer. Piezometer is a glass tube and pressure is expressed as height of this liquid column. So, that is equal to H equal to P divided by S into rho g. So, one of the limitation of piezometer is it is impractical for the measurement of large pressure. Another limitation is it needs a free surface of the liquid to measure the static pressure head. Piezometer is a glass tube and pressure head is expressed as P divided by S into rho g. If the specific gravity of this flowing liquid is less or the pressure to be measured is substantial, then height of this liquid column will be large. So that means we must use very long glass tube. So since it is a glass tube, it is very difficult to handle if it is long. Another thing is it needs a free surface. If you want to use piezometer for the measurement of the pressure of gas, it cannot be used because for a gas there is no free surface. So piezometer cannot be used for the measurement of gas pressure. Another limitation is it cannot measure the rapid change of pressure because actually the piezometer is intended to measure static pressure head. If the liquid that is flowing is of high velocity, then the bottom portion of this piezometer that must flush with this surface so that the velocity of this flowing liquid will not affect this reading. In order to overcome the limitation of the piezometer, we are using U-tube manometer or double column manometer. So this is a glass tube bent in the form of U. It has both the left and right limbs. It is exposed to atmosphere. And here we are using a manometric liquid with a high specific gravity. So normally we are using mercury. The manometric liquid used for the measurement of pressure depends upon the pressure range and the nature of the fluid whose pressure is to be measured. When the pressure is to be measured large, the manometric liquid of high specific gravity such as mercury can be used. A high specific gravity is used as high pressure can be represented by small liquid column. So for medium and low pressure range, other liquids like carbon tetrachloride or alcohol is used. Water also can be used as a manometric liquid when the measurement is to be made for gas. Normally, mercury is used as manometric liquid because it won't allow the mixing of the liquid with most of the other liquids whose pressure are to be measured. Now, if you want to measure the pressure, one of the limb is connected to the apparatus where we want to measure the pressure. Suppose this portion we are connected to the apparatus which is holding a liquid whose pressure is to be measured. Then if the pressure is higher than atmospheric pressure, it will be pushing this mercury down so that the level of mercury in the left limb goes down, whereas the level of mercury in the right limb goes up. So this can be explained by referring this figure. So this is the YouTube manometer. Here this portion we are connected to an apparatus which holds liquid whose pressure is to be measured. Now here you can see that pressure here is high. Because of the high pressure, it pushes the manometric liquid down so that here you can see a rise in mercury level. Similarly, if the pressure here is less than atmospheric pressure, then atmospheric pressure pushes the manometric liquid here so that here there is a rise in mercury level, whereas in this limb there is a drop in mercury level. Suppose we are using the YouTube manometer for the measurement of pressure in a pipe. So one limb is connected to the pipe. So this figure which shows the cross section of the pipe and the flowing fluid is water. So this is the point where we are interested to measure the pressure. So since pressure here is more than the atmospheric pressure, this liquid column, this water column pushes this mercury here so that you can see a rise in mercury level here. Px which indicates the pressure at the center of this pipe. So Y1 indicates the water column, whereas Y2 indicates the mercury column. Since all these dimensions are in length unit, pressure is to be represented in terms of pressure head. For writing the pressure balance equation, we have to consider two criteria. One is Pascal's law, which states that intensity of the pressure at any point in static mass of fluid is equal in all directions. That means 2 points in the same elevation in a continuous fluid at rest are at the same pressure. So as the pressure head is same above this horizontal datum line, the pressure in the left limb and pressure in the right limb we can equate. So that means we can equate the pressure at E equal to the pressure at F. Another criteria is hydrostatic law. That means dP by dz equal to minus rho g. So which indicates when we go down, that means elevation decreases, the pressure increases, whereas when we go up, elevation increases, the pressure decreases. If we are integrating this equation, we can write P equal to rho gh or pressure head equal to P by rho g. So this is in terms of water column. It can also be represented in terms of the liquid of other specific gravity as H equal to P divided by S into rho g, where S means it is the specific gravity of the liquid we are using. So here it is water, so that means the value of S equal to 1. Now we can write the expression for pressure at F by considering the other limb. Pressure here and pressure here are equal. Similarly, pressure here and pressure here are equal. That means Px equal to Pc and Pe equal to Pf. So if we are writing down the pressure balance equation, then we have to equate pressure at E equal to pressure at F. So pressure at E equal to, that is Px by rho g, which indicates the pressure head at this level, and to reach E then we have to come down. So that means Px by rho g plus Y1. Since it is water, so it is S value equal to 1. So Px by rho g plus Y1 equal to, that means Px by rho g plus Y1 equal to the pressure at this point. So this limb is open to atmosphere because we are representing that as a gauge pressure. So that means 0 plus SHG. SHG means it is the specific gravity of this mercury into Y2. So if you are simplifying this expression, Px by rho g equal to SHG into Y2 minus Y1. So Px by rho g indicates the pressure head at this point and it will be in terms of water. So this can be explained by an example. This example is similar to the situation explained here. So here right limb is exposed to atmosphere, whereas left limb is connected to pipe which contains water under pressure. So the free surface of mercury in the right limb and the center of the pipe are at the same level. So that means the level of mercury in this right limb is coinciding with the center of the pipe. So that means Y1 that is equal to Y2. Now we students get a confusion here. Since the Px and the water surface at this right limb are at the same horizontal level, will Px equal to Pd? It is a wrong concept as C and D are not connected by the same fluid and hence cannot be equated. So we can use the same expression to find out the pressure head here, that is Px by rho g equal to SHG into Y2 that is equal to 80 mm. So this should be converted into meter and Y1 that is also 80 mm. So we can find out Px by rho g that is in terms of meters of water column. If you want to obtain the pressure, you have to multiply this pressure head by rho g. So this YouTube manometer we can also use to find out the vacuum pressure also. So here you can see that the pressure of water is less compared to atmospheric pressure. So the atmospheric pressure is higher than the pressure of water. So that is why the level of mercury here comes down compared to the level of the mercury in the left limb. So in order to write down the pressure balance equation, again we have to consider Pascal's law, which states that pressure at this point and at this point are equal, that is Px equal to Pc and Pe equal to Pf. The second criteria to be followed is hydrostatic law. If you are integrating this, you will get P equal to rho gh or pressure head equal to P by rho g in terms of water column or H equal to P by S into rho g. So this pressure head will be in terms of the liquid column whose specific gravity is S. Next we can write the pressure balance equation. So it is Px by rho g plus Y2 into S. Here it is water, so the value of S equal to 1. So Px by rho g plus Y2. So that means up to this plus it is S into Hg into Y1. So that is equal to 0. So here it is atmospheric pressure. So we can find out Px by rho g equal to minus Y2 plus Hg into Y1. So negative sign indicates that the measured pressure is negative. Now we can discuss how a YouTube manometer can be used for the determination of difference in pressure between 2 points. So here we are going to find out the difference of pressure between this main line and this submain. So for which we connect the two limbs, one here on this main line and other at this point on this submain. So these two limbs are connected to different points and both cases the flowing fluid is water. So let us consider A is the point at the center of this pipe and B is the point at the center of this pipe. So Pascal's law states that Pa equal to Pc and Pb equal to Pd and Pe equal to Pf. Then based on hydrostatic law, we have to follow the sign conventions, that is positive sign while going down and negative sign while moving up. So our expressions are like this: P equal to rho gh and pressure head equal to P by rho g. So here H is in terms of meters of water column, whereas H equal to P by S into rho g. Pressure head is in terms of the liquid column whose specific gravity is represented by S. 2 points in the same elevation in a continuous fluid at rest are at the same pressure. So this is the result of Pascal's law. So that means P equal to Pf. Assume that we wanted to express the pressure balance equation in terms of water column. So now we are going to write down the pressure balance equation. So how to start? Pa by rho g plus Y3, because here it is throughout water and here it is, that is mercury. So we are multiplied with Y1 into specific gravity of this mercury. Okay, we reached at this point. Multiply this Y1 into specific gravity of mercury for converting the liquid column of mercury into water column. Now from this point, when we are writing, then Pb by rho g, so this is Pb by rho g plus Y2. So here also the flowing fluid is water, because we are going to find out the difference of pressure between the 2 points. In both cases the flowing fluid is water. So it is Pb by rho g plus Y2. So we are interested to find out the difference of pressure between these 2 points. So Pa by rho g minus Pb by rho g equal to, it is Y2 minus these two terms. So if you want to represent difference in pressure in terms of Pascal or kilopascal, then we have to multiply this term by means of rho g. You must be thorough with the conversion of pressure into pressure head. So the basic equation we have to use is hydrostatic law, or P equal to H rho g, or P equal to gamma H. Now let us discuss a problem with U-tube manometer. So here we are going to find out the pressure at this point. This flowing fluid is oil. At the right limb, the flowing fluid is water, but upper side some air is trapped and this air pressure is given to you. We have to determine the absolute pressure at A. So the two criteria to be considered is, one is Pascal's law and other is hydrostatic law. So based on Pascal's law, P equal to Pf, and based on hydrostatic law, that is P equal to rho gh, or H equal to P by S into rho g. Pressure of air here, that is given in kilopascals. So we are writing down the pressure equation in terms of pressure. So Pa, that is here, so Pa plus, here it is oil, so S into oil into rho g, so that is specific weight of the oil into Y3 plus then specific weight of mercury into Y1. So that means we reached here. So that is equal to pressure of air plus specific weight of water into Y2. So if you are substituting the corresponding values, you will get the pressure of oil 91.269 kilopascal. That is the absolute pressure at this point. So you can very well work out this problem. Now let us discuss about the inverted U-tube manometers. In inverted U-tube manometer, as shown in this figure, the manometric liquid is lighter than the liquid whose pressure difference is to be measured. The same principle is used in analyzing inverted U-tube manometer. 2 points in the same elevation in a continuous fluid at rest are at the same pressure. So this is a result of Pascal's law. In order to find out the pressure difference between these 2 points, we can use Pascal's law, which states that the pressure at these 2 points are equal. Then hydrostatic law, that is P equal to rho gh, or H equal to P by rho g, or H equal to P divided by S into rho g. So in this figure, SA indicates the specific gravity of the liquid, and SP, which indicates the specific gravity of the liquid here, and S indicates the specific gravity of the manometric liquid. So if you want to write down the pressure balance equation, we have to balance the pressure at this point E and F. So if you are writing the pressure balance equation following this Pascal's law and hydrostatic law, then we can write the pressure balance equation as, that is Pa, that is the pressure here, Pa minus, so in order to reach E, we have to go up. That means Pa minus gamma means specific weight of water into SA, that means gamma into SA, which indicates the specific weight of the fluid here, into ZA. So that means we reach at this point, that is equal to PB, that is the intensity of the pressure here. Then in order to reach F, then we have to go up. So that means PB minus gamma into SB indicate the specific weight of this fluid, okay, into ZB minus Y. So that is the distance from this point to this point, minus Y into specific weight of this manometric liquid. So we can find out Pa minus Pb. From this expression we can find out the difference of pressure between these 2 points, but it is not in terms of pressure head. Now the session comes to an end. Please watch my videos and comment. Your comments are highly valuable to me. For the time being, it is enough. Thank you.